If we have 100 cars parked in a car park, same security system is installed in all 100 cars. Same make and type from the same manufacturer. All remotes are similar. But when we will press this remote, why this car will open and how this remote communicates with this device. When we press any button from here, it will transmit some data. That data is being received here on this antenna cable that is connected at this module. Here is PT4303S. It is low power super heterodyne receiver. It is a complete radio receiver. When we press any button from here, from any keys, these are reaching to this IC. All these buttons are reaching here, 1, 2, 3, and this is fourth input. In this IC, a unique code that is stored here that consists a device identifier number, hardware ID for this JZY20140615. It will generate frequency at 433 MHz. When it is high frequency, that time it needs very small antenna. This track, it is working as antenna. Here is antenna driver, so it will transmit its own identifier number. What is hardware ID and what we need function, that is added in this frequency 433. So that signal will be amplified and that will be transmitted by this antenna. This antenna unit, it is receiving all type of signals. That signals are reaching to this point. Here is antenna matching unit, this spiral inductor, capacitor. It is reaching to PT4303. It will retrieve this code with that function and it will send to this microcontroller at this pin. This model can be connected to 315 MHz and 433 MHz because its remote is R433 433, so it is 433 MHz system. PT4303 low power super heterodyne receiver, OOK-ASK receiver. 4303 is low power super heterodyne receiver for 315 MHz and 433.92 MHz frequency. So it will work with wide range of frequencies. But in car remote central lock systems, these two bands are very familiar, 315 MHz and 433.92 MHz. It offers a high level of integration and requires few external components. There are very few components. Consist of low noise amplifier LNA, down conversion mixer, on chip PLL, phase lock loop, VCO, loop filter and demodulator, data filter and data slicing comparator, on-chip regulator, one-step automatic gain control to extend dynamic range of received RF signal, ultra low power consumption 2.7 mA for full operation at 315 MHz, excellent sensitivity, 2.4 volt to 5.5 volt supply, 250 MHz to 500 MHz frequency range, data rate up to 10 KB per second. It is used in remote keyless entry, remote control units, garage doors and gate openers, reference oscillator at pin number 14. In this unit, it is using 13.22 MHz oscillator. Different power supplies. Pin number 3 is antenna input, mixer out. After processing, it will provide data out from pin number 11. Here is typical application circuit. Antenna matching unit. Here is F1. intermediate frequency, that is this 3-pin resonator. Pin number 11 is data out. X1 reference oscillator. And here is component list. If it is designed at 315 MHz, these component values will be used. If it is designed for 433 MHz operation, these components will be used. X1 for 433 MHz, it will use reference 13 MHz. For 315, 9.5 MHz. In our case, it is 13.22 MHz. So this board will deal with 433 MHz frequency. If the crystal oscillator, this one, is 9.5 MHz, that will deal with 315 MHz. So this board is now dealing this range, 433, and this remote is also 433. It will receive supply voltage, ground, and final signal out. Now I will apply power and we will monitor the signal on oscilloscope and we will see how the code is working. Positive, and this is ground. Oscilloscope common to the battery common. Now I connected oscilloscope probe at that signal point that is coming out from this wireless receiver module. We have activation signal here now. When I will press any key from this remote control unit, it will transmit a code, that is hardware ID, that makes it unique for this device. It is matching pair, that when this remote will transmit data, it will receive. Other than this coded item, if any remote will send data, it will not respond. It will cross match the code transmitted from here and the code in this memory. If both codes will match, that time it will respond to this selected function. This time it is showing a random sync signal. We can see when I press this key, it is sending packets. It is special pattern data packet from here until here. It is hardware ID, and the last word here will define the selected function. If the first code, that high low 10101, these bits will match with this memory of this microcontroller, that time it will respond to this code. Let me save it here. Reference channel 1, save. Yes, this is the sample for this first key. Now I will press this button. Now we have two different signals. This key is here and this key is here. Both signals are same in this portion until here. it is defining hardware ID. Both signals are same. Yes, here is visible change in both signals. This bit is same, cursor function. This bit is same. This bit is same. Both signals are low. Then we can see this signal complete cycle here. This is high, then low, but it is still high. Here is difference, that it is not returning back to low position. Then this is high, but here is low. This is 1, then 1. This is 1, then 0. So this is the difference in these signals. Low, low. Then here is difference. In the last pattern, this word is different. This one is asking lock function and this is unlock function. Here is change. I hope this video is informative. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.